In last lecture we discussed about some numericals based on interference in the two-thread gearing. Interference in two-thread gearing. Continue with that numericals. We go through some numericals in this video also. So one numerical is shown here as a 20 teeth pinion has a circular pitch of 12.5 centimeter. It is generated by rack cutter. The addenda for pinion and rack are 3.4 mm each. Determine the least pressure angle which may be used while generating the pinion to avoid undercutting. Determine contact ratio for such pinion and the rack pair. So here one pinion is given having some number of teeth with some circular pitch. Again, there is a addenda for that pinion and rack is also given 3.4 millimeter each, and they asked to find out the pressure angle. Least pressure angle which may be used in this condition. They asked to find out the pressure angle. Again, they asked to find out the contact ratio. They asked to find out the contact ratio. So pressure angle and contact ratio are the asking quantity, and given quantity are the number of teeth, circular pitch are given, and addenda for the pinion and rack are given. So with this given condition we move further. So in last video we discussed that in for interference condition that addendum of the other wheel cut engaging gear to the base circle. So we consider maximum addendum for that particular gears so they cut that base circle of the other gear. And with such case we construct that, or we draw that particular uh, condition for that particular gear engagement. So in last video also we discussed some numericals based on this. Again we discuss in this video also some numericals, and then we move further. So here with this given condition we move further. So here they are given that here to condition to avoid undercutting, here we consider that number of teeth is equal to 2 into AR divided by sin square phi. So in undercutting condition we consider this number of teeth, minimum number of teeth to avoid undercutting. We have derived this formula in previous videos. T is equal to 2 into AR sin square divided by sin square phi. Now we also know that AR into M is equal to addendum. In undercutting condition. AR into M is equal to addendum is equal to 3.4. It is given in your problem. It is given in this numerical that addendum value is a 3.4. Now with this equation we can simplify this. By substituting that values, and after simplifying now with this m value, this model value we can it is not given. This model value is not given. So pitch circle circular pitch is given. PC. So PC is equal to pi into m. Circular pitch PC is equal to pi into m. So m is equal to PC by pi. Circular pitch is given. So module is given indirectly in terms of circular pitch, PC divided by pi. So instead of m we put as a PC divided by pi. Now this equation become AR into PC by PC by pi. Here there is a printing mistake. Instead of m, there should be pi. There should be pi. AR into PC divided by pi is equal to 3.4. Is equal to 3.4. Now put that PC value. Put that PC value. That PC is given, circular pitch is given 12.5 millimeter. It is given as a 12.5 millimeter. So put that 12.5 millimeter. So that AR comes as a 0.8545. That AR comes as a 0.8545. Now we move further. Now put this AR value into the above teeth equation. Above number of teeth equation. T is equal to. So put that value. T are given. T value is given. 20 number of teeth pinion is given. So T is equal to 20 is given. 2 into AR now calculated, AR 0.8545 divided by sin square phi. So in this equation there is only unknown is a phi. Only unknown is phi. We simplify this equation and we get phi value is equal to 17 degree. So angle of obliquity or pressure angle is now we calculated as a 17 degree. We calculated as a 17 degree. So this is one of the asking quantity. Now remaining asking quantity is to find out the contact ratio. Now contact ratio is equal to arc of contact. Contact ratio. This contact ratio is equal to arc of contact divided by circular pitch. Arc of contact divided by circular pitch. Now arc of contact is equal to path of contact divided by cos phi. Arc of contact is equal to path of contact divided by cos phi. So with this formula, so another asking quantity is the contact ratio. For this we should know this path of contact. We should know path of contact, and circular pitch is already given. So path of contact we can calculate this. In this condition, this path of contact now becomes as a A to B. Path of contact now becomes as A to B. This total length is A to B or B to A. So length BA represent the path of contact. So this BA we can find out by considering triangle. OBA. By considering triangle OBA. BA we considering by considering triangle OBA. So BA is equal to square root of OB square minus OA square. So this AB we can find out as a BA equal to square root of OB square minus OA square. So this is by using right angle, this is right angle triangle, so we can write like this: BA is equal to square root of OB square minus OA square. So OA, this OA length is equal to, again we can find out OA length, by considering other triangle. OA we can find out by considering triangle OPA. This O to A we can find out by considering this triangle OPA. Again it is a right angle triangle. So this OA we can write down this OA we can write down as a OP cos phi. So this angle is a phi. So we can write this OA is equal to O to P cos phi. So for this O to A we can write as a OP cos phi. Now cos phi is nothing but pressure angle. We already calculated here 17 degree, and OP is a particular pitch circle radius. OP is a pitch circle radius that we have to find out. And then we can find out this length BA. So we can find out this length BA. Now this pitch circle radius we can find out by using this module formula. Module is equal to nothing but D by T. d by t. D is nothing but pitch circle diameter. So here we have to find out the pitch circle radius. Here we have to find out the pitch circle radius. So this we can find out. This pitch circle radius here. This pitch circle radius here we can find out by using module is equal to nothing but a d by t. D is the pitch circle diameter. So to find out radius, we can consider as a d by 2. We can consider as a d by 2. D by 2. So not d by 2. For radius it is a 2 into r. For radius is equal to d is equal to 2 into r. So 2 into r divided by 2 into r divided by t. 2 into r divided by t. So by using this, now m is equal to m again we can find out as equal to pc by 2 pi. M is again find out as pc by 2 pi. So m is equal to d by t. D is nothing but diameter. Is a 2 times of radius, 2 into r divided by t. M is again we can find out by m. Pc is equal to pi m. So m is equal to pc by pi. So put m is equal to pc by pi. T value is known to you. So this equation now becomes as a Pc into T by 2 pi. Pc into T divided by 2 pi. So put values of Pc. Circular pitch is given 1.25 centimeter into teeth are given 20 divided by 2 pi. So this pitch circle radius now we calculate as a 3.98. So this addendum, this OB length is equal to OP plus addendum. OB length is equal to this O to B length. O to B length is equal to O to P. O to P plus this addendum. O to P plus this addendum value. So O to P is nothing but pitch circle radius plus addendum. So addendum value we already calculated. This addendum value already given. Not it is calculated. Addendum value is already given 3.4 millimeter. This value is given to you. OP value is nothing but pitch circle radius that you calculated right now. So this OB is now becomes as a OP plus addendum. OP 3.98 you calculated already. Addendum value is given 0.34. So this becomes as a 4.2 centimeter. Now we know this OB value. OA is nothing but OP into cos phi. So OP is nothing but a pitch circle radius that we already calculated as 3.98. So put this value and we can find out this path of contact BA is equal to, put these values. Path of contact BA is equal to OB square minus OA square. OB already calculated here 4.32. OB we calculated here as 4.32. 4.32 minus OP is equal to 3.98. Just pitch circle radius right now calculated. So put here and we can find out the path of contact is equal to this much. Now arc of contact now becomes as a path of contact divided by cos phi. So path of contact we already calculated as a 2.04 divided by cos phi. So this becomes 2.13 centimeter. And now contact ratio is equal to arc of contact divided by circular pitch. So this 2.13 divided by 1.25. This is the remaining asking quantity 1.7. So contact ratio here comes as a 1.7. So this is this type of numerical. So these numericals are very similar to each other. Only condition is that only some formulas are changing. For rack and pinion, that minimum number of teeth to avoid undercutting, that formula now introduced in this example. So these examples are very similar to each other with the same approach. Only some formulas are introducing. As in this example, there is a rack and pinion is given. So minimum number of teeth for avoiding undercutting, that formula introduced here. And then we move further to simplify that asking quantity. Now we move further to the next example. Like this. two gears of pitch circle diameter of 75 millimeter and 250 millimeter have involute teeth of 5 millimeter module. Also, and 20-degree angle of obliquity, the addenda are equal and it is as large as possible while avoiding interference. Find addendum contact ratio and sliding velocity in terms of pitch line velocity at the first point of contact if the pinion is the driver. Now it is a gear and pinion arrangement. It is a gear and pinion arrangement. In last example, it is a rack and pinion arrangement. In last example, it is a rack and pinion arrangement. So in last example, if you look at this diagram, so in this diagram, for rack, that for rack, that addendum circle, pitch circle, uh, pitch circle line, that are straight lines. If you look at here, for rack, this addendum circle line, pitch circle line, and again one base circle line is also there. So these are straight line for rack. Now in next example, so and for pinion, it is a circle one. Three circles are given. For base circle, pitch circle radius, and the addendum radius. For rack, it is represented by straight line. Now in next example, these are the two gear wheels. So both are represented by circle. So one gear represented by three circles: base circle, pitch circle radius, and the addendum. Another gear represented as a base circle, pitch circle radius, and the addendum. So with this again, this is similar. In last video also discussed that same similar approach, very similar approach. So here also base circle is given, pitch circle radius is given, addendum is given, and as it is a interference condition, so addendum of the one of the gear is a cut the base circle of the another gear, Now with this given condition, we move further, and they asking addendum to find out addendum contact ratio. So again we have contact ratio. We have to find out the arc of contact. From that arc of contact, we have to find out the contact ratio. As a contact ratio is equal to arc of contact divided by circular pitch. Arc of contact, again this arc of contact is equal to path of contact divided by cos phi. So here in this example, this pitch circle diameters are given. Module is given here also 5 millimeter. Pressure angle is given 20 degree, and they are asking to find out addendum contact ratio and sliding velocity in terms of pitch line velocity. So with this diagram we move further. Now here this r is equal to pitch circle diameters are given. So pitch circle radius we can find out. Pitch circle radius now becomes as a d by 2. So these values are given. 75 values is given. 75 by 2 is equal to 37.5 millimeter. Now RB is equal to RB. Now the all other quantities are calculated by using the trigonometry. RB is equal to R cos phi. This RB is equal to R cos phi. This RB is equal to this R. Now considering this triangle. Now this RB is equal to this R. This is nothing but this length. This length is nothing but R into cos phi. So RB is equal to R into cos phi. Now PB is equal to now RB we calculated here. To find out RA value, to find out this RA value, we consider this triangle. We consider this triangle. We consider this triangle. To find out this RA value, we consider this triangle O2PB. We consider this triangle O2PB. Now, to find out RA, we can write as a RA square is equal to, considering this triangle O2PB, considering this triangle O2PB, O2PB, this triangle. Now, for this triangle, we can write as a RA square. We can write as a RA square is equal to R square plus PB square minus 2 into side lengths R and PB, 2 into side lengths R into PB, and angle between them by these two sides, angle between them by two sides, remaining two sides. So angle between the remaining two sides is a O2PB. Angle between remaining two sides is a O2PB. So RA square is equal to R square plus this PB square, R square plus PB square minus 2 into R into PB and angle included in between the remaining two sides, cos O2B, cos O2PB. Angle between this remaining two sides is nothing but this angle. Angle between remaining two sides is nothing but this angle O2PB. So this angle, with this equation, now put the values whatever that known to you. Now this now with this given equation, in this given equation we have to put values. So this P into B, so P into B, we already P into B we can calculate it. Now in this equation, this P into B, this PB is equal to R sin phi. PB is equal to R sin phi. By using that triangle O1PB, PB is equal to R sin phi. Here this PB is equal to R sin phi. This P into B is equal to R into sin phi. This is nothing but R, and this PB is nothing but a R sin phi. This is nothing but a R sin phi. Now with this R is known to you, phi is known to you, so we can find out this PB value. Now put all these values. PB, R is given, phi is known to you, then RA is equal to, this RA value comes as a 130 millimeter. So addendum of that particular wheel is equal to RA minus R. 130 minus 125, we can get it as a 5 millimeter. Now in this given problem, both the addendums are given same. It is given in your problem. Addendum of that wheel and addendum of the pinion are same. So this we can write as a this is same. So we can write like this. RA is equal to R plus addendum. So we will get this equation. Again simplify this equation. Now we have get this equation. Again for this triangle, considering this triangle AP, O1AP, we can again write similar to this triangle. Previously we write that equation for this triangle. Similar to this, we can write that equation for this triangle O1AP. Similar to this triangle, we can write equation for O1AP. Similarly, we write here as a RA square is equal to, we write here as a AP square. RA square is equal to R square plus AP square plus 2R into AP into sine 20. So after simplifying this equation, so put values of, now here RA value is known to you, R value is known to you, RA is known to you, sine 20 is known to you. Now AP value Now here this AP value you have to find out. AP value you have to find out. So unknown is only RA given, R given, sin phi is given. This also R is also given. So AP is unknown to you. AP you can find out by simplifying this equation. We have to find out this AP value as a 10.93 millimeter. 10.93 millimeter. Now we find out this two length. We find out this two length AP and BP. So addition of this will give total path of contact. Now contact ratio is equal to arc of contact. Arc of contact again path of contact divided by cos phi. Arc of contact is equal to path of contact divided by cos phi. This is the arc of contact, and divided by PC is equal to pi m. PC is equal to pi m. So put all these values. Path of contact you already calculated 23.755. Cos phi is a cos 20. M value is given as a pi into m. M is 5. So contact ratio now becomes as a 1.61. Now here velocity of sliding, third asking quantity is a velocity of sliding at point B. At point B we can find out as a omega 1 plus omega 2 into PB. Omega 1 plus omega 2 into PB. Now to find out omega 1 that speed is not given. Speed is not given. So we have to write down this omega 1 as a pitch line velocity as a V by R. Pitch line velocity is equal to, in terms of pitch line velocity, is equal to V by radius, pitch circle radius. So omega 1 for that particular wheel, that radius is a small r. Omega 2 for particular wheel, that radius is a capital R. So V by small r plus V by capital R into P into PB. So PB we already calculated. This PB we already calculated here. PB already calculated. This PB we already calculated here in this value. This PB we already calculated here. So 12.825. This value PB we calculated already, 12.825, and remaining term R and small r and capital R is also given to you. Small r and capital R we calculated already. Now we put these values. Now here in this numerical, R is known to you, this capital R known to you, PB is known to you. So put all these values in this numerical, in this equation, and we will find this pitch line, and we will find that velocity of sliding in terms of pitch line velocity, as a 0.446 V, So in this example, this speed is not given. So this sliding velocity we cannot get in terms of number, but we can find out in terms of the pitch line velocity small v. So these are some numericals discussed in this video. We go through some other numericals in next video about the 2-3 gears.